session of the workshop. I'll just find my pointer. Point options. Right, here we go. Okay, so what we'll do, we'll do a recap from last time, just so that we can remember what we did, and then we'll have a look at some of these less, or what I've called less common minerals. It depends where you are as to be whether they really are less common or not. And as usual, we'll have questions at the end of the session, and it'll probably be just around an hour or maybe a bit less. Right, okay, what did we do last week? Well, quite a lot actually. We looked at pyroxene, and really we were talking about augite was the main one we were looking at. I think the crucial things about that was it was fairly stumpy prismatic crystals, had a cleavage which we could observe under most conditions, and these sort of dark colors. I'll summarize those in a moment. We also looked at the other pyroxene diopside, and this is another relatively common pyroxene, but it's quite different because it's green. And so that was the giveaway for that that pyroxene. But again, it would have had this longitudinal cleavage, and again the stumpy prismatic crystals. Then we moved on to the hornblende type amphiboles, and these are characterized by these bladed prismatic crystals, very glossy as well, quite a vitreous plastic to vitreous luster, almost as glossy and vitreous as the micas, but not exactly. They had cleavage as well, but if you are lucky enough to find a basal section, then those had a pair of intersecting cleavages would have made an angle of around 120 degrees. And these were in these black, dark colors. We then, for completeness, had a look at the amphibole glaucophane, and very similar characteristics to the rest of the amphiboles, but the major difference was this deep indigo blue color for glaucophane. Then we moved on to some of the other dark minerals that were relatively common, and the dark mica, which is generally called biotite, but remember biotite is a particular chemical composition, and you don't necessarily know the composition when you're looking at something in hand specimen. But biotite, dark, as the name implies, dark mica, black to dark brown. And we had this other variety of a darkish mica, which is the magnesium mica phlogopite. And that was characterized by this pale bronze color indicated there. So those are some of the main aspects of what we looked at last time. We've done quite a lot now in these last sessions. So let's do a quick summary of exactly whereabouts we are. Well, right at the very start, and you've probably forgotten this now, we looked at some granular anhedral glassy minerals, and we recognized olivine and quartz amongst those granular anhedral minerals. And we could separate olivine and quartz because, generally speaking, olivine was an olive green color and quartz was colorless. We also looked at plagioclase, and in some instances, because plagioclase is translucent and it can be quite transparent at times, there could be confusion between the translucent plagioclase and the granular quartz. That is, if you don't have proper euhedral crystals of plagioclase. But my advice was that if you hunted around on the hand specimen and you did find euhedral crystals with this transparent or translucent appearance, then everything that you were looking at that was granular was actually anhedral plagioclase. So that was a significant thing to remember. It is unlikely, again, I said this in the session, it's unlikely that you will find plagioclase and quartz together unless you are in some very particular rock types. It's not common. So generally speaking, plagioclase and quartz, you would need to think, if you think you've got both of those in your hand specimen, you would need to think carefully whether your identifications are appropriate or not. We then moved on to the alkali feldspars. We recognized those again with this euhedral lath-shaped crystal with a satin luster, and these were opaque. And remember, I mentioned a rule about the alkali feldspars. Well, it's actually a rule about plagioclase, and that was that plagioclase was never pink. So if you had some pink, opaque, lath-shaped, satin luster crystals, then they had to be alkali feldspar. Then the micas, characteristics of the micas is very glossy luster, what we call plastic or very vitreous, occurs as flakes and little flecks within our specimens, unless we've got a lot of it. And if we have got a lot, it appears like sections of books. You look at a book end on, and the leaves of the book are the individual flakes, the individual cleavage flakes of mica. And I mentioned just a moment ago that the characteristic way to identify pyroxenes is this euhedral, stumpy prismatic crystals, generally dark, unless you happen to be dioxide, in which case you're that nice bright green. But these have, they all have cleavage, 90 degrees if you have a basal section. And those are separated from the amphiboles, whereas the amphiboles tend to have more bladed crystals, acicular bladed needles even, crystals with a glossy luster. And the luster of these amphiboles is greater than that of the pyroxenes. So if you've got two together, the ones that are most glossy will be the amphibole, and the ones that are less glossy will be the pyroxenes. So that's a summary of all the last several sessions in a way, but these are the things that I hope you'll remember so that you can be able to identify some of these minerals when you get an opportunity to look at them in the field. All right, so let's move on now. Okay, right, from what we've just been saying, hopefully your memories aren't too short. Oh, look what we've got here. That is a granular glassy. There's another little one in, oh, there's one there. Granular glassy. There's another one there, a granular glassy anhedral. It doesn't have any crystal shape. There's another one there, possibly. Seen quite a few in here. Can't pick out any more instantly visible, but this anhedral, broken, glossy, glassy, should be ringing lots of bells in your mind, and you should be saying to yourself, aha, I know what that is. And here's some more. Just take a note of the scale bar there. That's a 2 centimeter scale bar. And all this stuff here, look, there's loads of it. No proper crystal shape, but this glossy, glassy, look at it all over the place. It's full of it. Everywhere there. Possibly slightly grayish. There's some bits in there, bits there. It's all over the place. This is full of it. This nice glassy anhedral. No shape, no proper shape, granular, like broken glass. So hopefully you'll all know what that is. And if you've all said independently that, that's quartz, then you can give yourself a gold star, because that's what you would have identified given the criteria that you've currently got. Sadly, though, it's not quartz. Why isn't it quartz? Because it follows most of the characteristics that quartz has. Well, here's some more of it. There's my scale bar down there. That's 1 centimetre. Well, here we are. There's glossy anhedral, like broken glass. It's there and it's there and it's there. But, oh, what have we here? That's almost, well, I would call that subhedral. Possibly a cleavage along there, or maybe a cleavage down there, possibly. Bit hard to tell in this. But when you get lots of this stuff, it's not exactly anhedral. But the other mineral that you will recognize as being somewhat good shape, those nice lath-shaped plagioclase crystals, which I'm sure you're all thinking about at the moment. Well, this isn't really lath-shaped, so it's not a plagioclase. But what this is the mineral nepheline. And the way you tell the difference between nepheline and quartz, when you haven't got any nice, well, reasonable shapes like that, is that imagine quartz, a nice rounded granular glassy grain. Imagine you've got a nice granular glassy quartz grain and you've smeared it with Vaseline. That's what these little grains look like, as if they are, it's what we call greasy. And all these ones here look as if they've been smeared with Vaseline. And greasy is the term we give to the luster of these nepheline, well, particularly nepheline in its anhedral state, because that's the most likely way you can misidentify nepheline. This big piece here, this subhedral piece, again, it's got that, well, greasy appearance. And what we can do is, if we compare quartz with this anhedral material, as I've got here, the thing to note is that the left-hand side is quartz, and this nice piece of quartz here, this is bright. This is bright and shining. It really looks bright, glassy, broken glass. Whereas this stuff, it's got that slightly less bright, and as I say, this more greasy appearance. So if you took this nice quartz crystal, well, it's not a crystal, anhedral crystal, if you want to call it that. If you took that piece of quartz and smeared it with Vaseline, that's what it would look like. So if you've got something that you think is quartz, but you have a feeling it might be a little bit greasy, then you've identified nepheline. Right, summarize some of those ideas about what nepheline really looks like. Well, it's generally colorless or has this slightly grayish color, but it can under some circumstances be white as well. So all the things I've just said, instead of it being colorless, it would be white. Less easy to mistake it with quartz. And it's the colorless to gray material that is the most prevalent. It is transparent, but it can veer towards somewhat translucent, in which case it looks rather like plagioclase, only you don't have those lovely plagioclase euhedral crystal laths. The giveaway, as I've just said, it's got a glassy vitreous luster, but it's greasy. So you imagine smearing Vaseline over it, and that's the giveaway for nepheline. It is generally anhedral, only, as I say, when you get a lot of it, then it can become subhedral. So you can start to get some reasonable crystals, or well, sort of reasonable crystal. At least you can get crystal edges and some faces. It has a cleavage, but it's not very well developed, and you're unlikely to see that. So putting that into our current format now, as we've been building up this this format, this way of describing in a tabular form, there's the anhedral generally granular, but it can have this somewhat prismatic appearance, transparent to translucent, greasy. Remember that nepheline is greasy, poor cleavage, colourless to grey. It does have twins, but you won't see them. Very rarely will you see those. See the twinning in nepheline. Now, what is nepheline? Well, nepheline is, I like to call it an almost feldspar. It's one of a group of minerals that we call the feldspathoids. Now, I think this is an American term, but it's a modern term calling them foids. I don't like that. I like to call them feldspathoids because it says something about their origin. They are almost feldspars, and that's exactly what they are. They would be feldspars if you had enough silica in the magma that was crystallizing. So if you had enough silica, then you would have enough silica to make proper feldspars. But if you're silica poor, what we call silica undersaturated, then there isn't enough silica to make nepheline, which is an aluminosilicate, a sodium aluminosilicate. If there isn't enough silica, then you make these feldspathoids instead. Nepheline is one of the common feldspathoids. Now, because what I've just said about it occurs in silica poor rocks, you will never find, well, now that's a dangerous word, isn't it? You're 99.99% sure that you'll never see quartz with your nepheline. Because if you had quartz there as well, you wouldn't have nepheline because you'd have made a feldspar out of it. Only under some very rare, tiny proportion where you get some late stage quartz crystallizing as the melt is finally cooling and without chance for the quartz to react with the rest of the melt. So when you are doing your identification, the question you need to ask yourself is this ID realistic? Do I really think this is nepheline? And that's where you would look at the other minerals that you think you've got in your hand specimen. So, for example, as I said, if you think you've got quartz in there as well, you've made a mistake on one of them. So that is nepheline. And nepheline occurs in groups of rocks. It will occur in alkaline rocks, alkali-rich rocks. You can get nepheline because a lot of the alkali rocks and things like cyanites, for example, a lot of the alkali rocks are low in silica because of the very low degree of partial melting, which gives you both low silica and high sodium content. So nepheline is one of those relatively rare rocks, but you could come across it. Right, let's look at this one. Splodges. There's our 2 centimeters. So these are quite large white splodges. Nothing much to say about those splodges. Let's have another view of some more white splodges. No real crystal shape on these splodges. There's lots of them there. Possibly something going on there, which we'll talk about in a minute. Possibly something there. But not really much to speak about there. Another view of, that's probably the same one. Some white opaque material, and possibly a little bit more translucent in there. White with something translucent. So maybe these splodges aren't all just one thing. And there's the scale bar for this one. That's 1 centimetre. So we've upped the magnification on this one a bit. And while we're looking at this, the thing to note is that this splodge that we're looking at here, which is a couple of centimetres across, 2 to 3 centimetres, it's got something translucent in the middle, and it's got some white stuff around the outside, and there's a bit more white stuff which is opaque, translucent, almost glassy in the middle, and there's some more glassy stuff there, translucent glassy material with some white opaque material there. And I think that's the last slide. Yeah. So what we've got there, this is lucite. Well, it's not actually. It was lucite. And the lucite has altered. Lucite is another one of these felspathoids. So this one is again, it's a sodium-rich felspathoid. It's another one of these aluminosilicates. And again, it's formed when there isn't enough silica to make proper lucite. To make proper felspar. Now, lucite is relatively unstable in a lot of rocks. And so instead of having lucite, you normally end up, or you often end up, with the pseudomorphs after lucite. Now, lucite is an octahedral shape, it's an octahedral crystal, and so the pseudomorphs will take on somewhat of this octahedral shape. And these octahedral, that's what the white splodges are. You know, the remains of the octahedral, where the octahedra were. That's called pseudo-lucite because it was lucite. Now, what the splodges are beginning to convert into, what pseudo-lucite is, aggregates of nepheline and alkali felspar. So the white opaque material around the outside, as it says here, little subhedral, possibly some lath shapes when it's sort of quite well developed, those are the alkali felspar breakdown products of your lucite. And the center, the other alteration product of lucite is nepheline. And it's the nepheline that is generally on the inside, and it's that glassy vitreous, and again, it's that greasy material that we saw in those sections. Again, it's granular, won't have any real good crystal shape. So the way to identify lucite, does it first of all, does it look like sort of octahedra? Broadly speaking, that is. And if so, then you've got white splodges. Can you see within the white splodges any indication of glassy, greasy nepheline with the more opaque white material around the outside? So that's another one of these felspathoids. Again, it's not common, but you do find it, and you find it in some alkali cyanites, and these are reported from Britain. So we do find these pseudo-lucite bearing rocks within the British inventory of igneous rocks, Caledonian igneous rocks. These ones will be. So that's two of the felspathoids. There are quite a few, but I'm doing the more common ones. There's some that you don't find very, very often at all. I'm not considering those at all. Right, let's look at the general rundown for our pseudo-lucite. Anhedral, yeah, and it's spots, technical term if you like. Transparent to translucent, well, it's the transparent stuff which is the nepheline, and the translucent which is the alkali felspar. And as I say, it's the greasy material which is the nepheline. Opaque is the alkali felspar. You yeah, you won't find any cleavage. You won't find twinning generally because the crystals aren't developed well enough for that. The colour is white to grey, and that's a rundown of pseudoleucites. That's another one of the felspathoids. Right, centimetre scale bar. So this is a slightly finer grained. Quite a lot of dark minerals in here, but it's these white bits, these white patches. One patch there, a white patch there, some white material there, white material there, and there, and there. If we have a look at that under a different, there's some more of it. Okay, and there's your scale bar. Now, this material here, beginning to have a bit of this some crystal shape developing here. There's a bit more with a bit of crystal shape. Some bits possibly there, a little bit more of a getting to the point of being subhedral. That is, well, a bit messy there, a bit there, but quite a lot of it in this particular rock here. Again, with these dark minerals, stumpy black crystals, which you'll know from last time, these are pyroxene. But this material doesn't fit into any of the previous things that you've been looking at, and it doesn't even look like the pseudoleucite spots. You haven't really got anything in the middle, it's just one thing. And this is another, well, it's debatable what you would call this. Technically, well, this is analcite. Technically, analcite is generally classified as a zeolite, but it's almost close to being a felspathoid. And so technically, as I say, it's not a felspathoid, but it's very, very close to being a felspathoid. It's got sodium and it's an aluminosilicate, just the same as the felspathoids. But on crystal grounds, it's classed as a zeolite. So what are the characteristics of this analcite? Well, white spots, single component, that's the differentiator between the pseudoleucite that we saw just now and analcite. It's white and it's opaque, and sometimes you get it's becoming subhedral in terms of, you do get good crystals, but they're not formed, generally speaking, under normal modes of formation, i.e. crystallization of igneous rocks. One of the giveaways is that it is often associated with mafic igneous rocks, mainly volcanic. So lavas or the shallow intrusive rocks such as dikes and sills can contain analcite. And indeed, in the British Paleogene igneous province up in developed in the northwest of Scotland in the Hebrides, there many of the mafic minor intrusives are analcite bearing. So if you have a rock sample from northwest, well, the Hebrides, for example, Mull, Rumsky, somewhere like that, if you've got a hand specimen from there and it's got these white spots, then it could very well be analcite. When and again, these are particularly noticeable in the weathering products of the British Paleogene igneous province basalts, for example, you get a lot of zeolites developed during late stage alteration of the magmas as they have been erupted and are cooling, and you have water circulating in the area of the eruptions. Much of the feldspar in the primary igneous composition will weather and alter to zeolites. And so you can get analcite formed as part of that process. And I'm sure many of you will have remembered the classic white spots within many of the volcanic rocks of the Hebrides, and quite pretty crystals of these zeolites. So that's another one of the well, zeolites or felspathoids. I prefer to group them with the felspathoids because they have a similar derivation. But as I say, again, association is a crucial thing. Check out what they are associated with, and if it is a volcanic rock, then you can be reasonably certain that you're looking at an calcite. If you've got the other zeolites, they tend to be more creamy coloured, pale red, brown, even green, pale green. So they tend to be more coloured than the white of the analcite. Right, so that's analcite. Let's stick that into its general format now, so that we can be uniform in what we're doing. So anhedral spots to subhedral, opaque, subvitreous when we've got enough of it. Can't see any cleavage, can't see any twinning, and it's this white to grey colour. Right, so those are the felspathoids. There's our scale bar, that's our 1 centimetre. Now, these long black crystals, quite a lot of long black crystals. You've seen long black crystals recently, and you saw amphiboles as long black crystals. But when you look in a bit more detail at these long black crystals, and look at the luster particularly, remember only a few minutes ago I mentioned that the amphiboles, the luster of the amphiboles was quite glossy, very, well, almost plastic, metallic luster. And these long black crystals, these ones, for example, that one, these are nowhere near as glossy. So that rules out amphiboles. So these aren't amphiboles. So they're not glossy enough to be amphiboles. Remember, the other dark mineral that we've learned to recognize are the pyroxenes, but we had nice stumpy crystals. Well, these are no way stumpy crystals. So these are something new. These are different. You might be able to see on this one possibly some striations, longitudinal striations, possibly on that one, possibly there. It's not very clear, and it's not very well developed. So quite a lot of black, not ideal crystal shape, not perfectly terminated, for example, but subhedral at least. Let's have a look at another piece. There's a bit more detail. Here you can see there are some striations on that piece, slightly more lustrous, but nowhere near the glossy plastic luster that you would need to be able to identify this one as an amphibole. So this is something quite different. And again, let's look at the scale bar there. So these are quite big crystals here, quite long crystals. Now this is an oblique section, but we're beginning to see something of the giveaway shape of it. And here, this one here is a proper basal section. So we're looking sort of end on, like one of these elongated, we're looking end on into that. So that's what this is. And it's got this three-sided, well, almost three-sided appearance. The edges are beveled. You've got a beveling around here, and that's all broken away there, so you can't tell it really. But This three-sided appearance, and if you've got the beveling developed as well, that's another giveaway. That is diagnostic for this mineral. I've just noticed a little bit more, some striations on that bit there as well. Is that a three? Well, it is three-sided, but it's not particularly beveled. But this one, remember this one, that is quite a nice diagnostic piece. So when we now look, there's a 2 centimeter scale bar, so it's some really big crystals, and here's a nice elongated piece along there. But here, this is a basal section, and there's 1, 2, 3 nice three-sided crystal, and these edges are sort of beveled, sort of rounded. And what this mineral is, this is tourmaline. This is the mineral tourmaline. Call it tourmaline. It is also called schorl. This is an old name. It's a German name. And it's what tourmaline associated with quartz and various economic minerals used to be called. And if you are down in the West Country, you get a lot of tourmaline in the granites, the Cornish granites, and that used to be called schorl as well. But in the earlier literature, you will find the term schorl for the tourmaline in the Cornish granites. But the important things about the crystals, they're euhedral and they're prismatic, and they have this elongate shape. And talking about shape, I mentioned this three-sided in section. So we've got a basal section. I've got these three-sided, and the edges are beveled. So that was the crucial giveaway for those crystals. This vitreous to subvitreous luster, and remember, it's much less glossy than the amphiboles, which is the other elongated crystal that you could mistake for tourmaline. Usual color is black, can be dark brown, and it's generally opaque, although there are translucent varieties, and some of the more translucent ones, particularly if they've got various trace elements in, have all sorts of colors of reds and greens and blues even, and they are semi-precious gemstones. So you can have some very, very pretty tourmalines, not common, of course. So let's put tourmaline into our set of tables. So the crystal habit, euhedral, prismatic, and it's this three-sided section. That's the giveaway if you've got basal sections, and when you've got lots of tourmaline, yeah, the chances are you will have basal sections by chance, so you'll be able to identify it from that. It's opaque. It can be translucent, as I just mentioned, when you've got the gemstone quality. Subvitreous luster, technically the term is subvitreous. Doesn't have any cleavage, but it's got those striations. They aren't cleavages, but it does have striations if you've got good, properly formed crystals. And the color is this black, generally black, can be brown. If you're in the opaque varieties, you don't generally see twinning with these materials. So that is tourmaline. So these, what we've looked at here, are a series of the somewhat less common minerals. But if you are in these particular areas, for example, if you're in the Northern Highlands and you're looking at strange igneous rocks, plutonic igneous rocks, and you could be looking at nepheline and you could be looking at cyanites. So if you are in that region and you are looking at these rocks, then instead of these being rare minerals like nepheline, they are very plentiful. And the same with pseudoleucite. That in certain areas that is very plentiful. If you are in the Hebrides and you're looking at volcanic rocks, then analcite will be leaping out at you all over the place. Very common in the minor intrusives and the volcanics of the Paleogene igneous province. And if you're down in the West Country, looking at the Cornish granites, then tourmaline will be pretty common there as well. So, yeah, these are less common minerals, but when you do find them, they are pretty plentiful if you know where to look. Right. Let's try and move on. Right. Okay. What have we learnt so far in this session? Well, hopefully we can now identify nepheline. Glassy, granular, and it's that greasy color. Remember, you get quartz, you get a fingerful of Vaseline, you smear it over the quartz, and it looks like nepheline. So that's what nepheline looks like, and it's colorless to white. Pseudoleucite, it's got white spots, but these aren't just ordinary white spots. They've got generally two things in them, and you should be able to identify the nepheline, which is that more glassy granular material, and the more opaque alkali feldspars, which are the breakdown products of nepheline, of leucite. The analcite you can identify as this white opaque material, generally anhedral, but it can be subhedral, and this is often occurs as spots in these volcanic and minor intrusive rocks of the Paleogene igneous province in the Hebrides, and the elongate black prismatic three-sided crystals will be the tourmaline, which is black. So that's the rundown of the things that we're going to cover tonight. For the final session, we're going to look at some metamorphic minerals. Now, I did promise this right back at the very start that we'd look at some metamorphic minerals, and we'll look at some of the somewhat more common metamorphic minerals, other than the commonest, because we've already done the commonest metamorphic minerals, believe it or not. The micas are very common. The amphiboles are very common. The feldspars, particularly alkali feldspar, these are very common in metamorphic rocks. So we're not going to cover those because we've already done those. But we'll do some other somewhat less common, but nonetheless abundant metamorphic minerals, just to add completeness to the session. Right, okay, I'll stop sharing and open it up for any questions now. I'll make myself